Alright, so we are in section 3.6 where we are multiplying um, matrices. And we talked about adding and subtracting matrices in section 3.5, and the rule was if you were to add or subtract matrices that they would have to be the same dimensions. So if you were to have, say, like a 3 by 2 matrix for one, and then say you were going to add another one, it would have to be a 3 by 2 matrix in order for that operation to work. Well, it's a little different when it comes to multiplying matrices. So say I have my matrices A times matrices B, and the deciding factor on whether or not you're able to multiply the matrices or not is that in matrix A, the number of columns must equal the number of rows in matrix B. So both of the n values must be the same number. And when you multiply those together, once you've identified that the columns in matrix A are the same in the rows in matrix B, and what you're going to get is you're going to get a whole new dimension for that product. And the product dimensions are going to be, rows are going to be dictated by the rows of matrix A, and then the columns are going to be dictated by the columns in matrix B. So you're going to have a matrix that has the dimensions of what is considered M times P in this general format. So for the first examples, I want you to tell whether the product A times B matrix can be defined, and if so, I want to know what the dimensions are going to be. So if I got matrix A is a 4 by 5 matrix, and I got matrix B is a 5 by 19, I look here, I see 5 and 5, they're the same, so now I can multiply them. And once I multiply them, I know that it's going to be a 4 by 19 matrix. So yes, I can define this by the product, and it is a 4 by 19. Here, A is a 3 by 6 and B is a 3 by 6. And as I look here, those values do not equal. So since they do not equal, I cannot multiply those two matrices, so it is not possible. Okay? Here's kind of a general format in looking at matrices and being able to find the products of them. And here's the best way that I can explain this. Here is that slot right here is considered row 1, column 1. Okay? So in order to multiply row 1, column 1, I'm going to use the rows in matrix A and then the columns in matrix B. So I got row 1, column 1, so row 1 in matrix A, column 1 in matrix B. And that's where I'm able to use my values of A times E plus B times G. And if any of you guys have ever played like Scrabble or Words with Friends, I suggest to make these like cubes, okay? And what I would like you to do is when you realize that, like, so say this first one here is this is row 1, column 1. So I would like you to pull out values A and B and then turn it clockwise 90 degrees. So when you turn it clockwise 90 degrees, you're going to get A here and then B here. So then you multiply those together. Multiply those two values together and then you add them. Same thing works for let's see if I erase this here. Same thing works for this one here is row 2, column 1. So row 2 means I'm going to take row 2 of matrix A, but I'm going to use column 1 in matrix B. So I'm going to pull out C and D, turn it 90 degrees, and then I got C and I have D. So that's where I get the CE plus the DG. Here, this is my row 1, column 2. This is row 2, column 2. And again, you're just going to be pulling out those rows from matrix A, turning it 90 degrees, and that's where we're going to get our values for our different column row relationships for our product of our matrix. So if let's do some examples going. So here I have some examples of matrices A through F. And what I'm going to do beforehand is I'm going to write down the dimensions of each of these. So A is a 2 by 3 matrix, has 2 rows and has 3 columns. B is a 3 by 2. C is a 2 by 2. D is a 1 by 3. E is a 2 by 2. And F is a 3 by 1. So when I go to my examples here, it says C times D. So what they want you to do is they want you to take the matrix C, take those values and multiply it by matrix E. So I'm going to plug in that matrix. So C happens to be 9, -1, 0, -2. And E is 7, 11, 2, -3. So when I multiply these together, again, I have a 2 by 2 and a 2 by 2, so I'm still going to have a 2 by 2 matrix here due to my the outside values being 2. So here I'm looking at row 1, column 1, so I'm going to be pulling out my row 1 of matrix C, turning it on its side, and then using those products and then adding them together. So that would become 63 plus a -2. If I go to row 1, column 2, I'm going to use row 1 of matrix C and column 2 in matrix E. And when I do that, that becomes 99 plus 3. Again, you're going to pull out that 9, turn it on its side, and then multiply those relationships. So here I have row 2, column 1, so I'm going to use row 2 in C and row 1, or column 1 in matrix E. So this becomes 0 plus a -4. And then the last one, I'm using row 2 in C, column 2 in E. So that leaves me with 0 plus 6. And then when I add these together, I get 61, 102, -4, and 6. Now let's try EC. So this is going to prove something, and I'll show you it in a minute. So if I go at 7, 11, 2, -3, and now I have 9, -1, 0, -2. Again, this is still going to be a 2 by 2 matrix. Row 1, column 1, so I'm going to use the row 1 in E, but the column 1 in C. So this becomes 63 plus 0. I got row 1, column 2, so I'm going to use row 1, so I got 7 and 11, turn it on its side, so that becomes -7 plus a -22. This is row 2, column 1, so I'm using row 2 of E, column 1 of C, reversing them together, so it gives me 18 plus 0. And then lastly, I have row 2, column 2. So I'm using row 2 of E, column 2 of C. So that gives me negative 2 plus 6. So when I add these together, I get 63, negative 29, 18, and 4. And as you look, these two matrices are not the same. So what that's telling us is that the product of matrices is not commutative. Excuse me. You know, when we have, say, like 4 times 5, we can rewrite that as 5 times 4. It's still going to be 20. It means number relationships, multiplication is usually commutative. In matrices, it is not. So keep that in mind. We look at C. It says I have matrix A times matrix B minus by matrix E. So again, we're going to use order of operation to help us out. So we first have to take the products of A and B. So now I have 2 and 3, negative 4, 0, negative 5, and 2. And then multiply it by B, which gives me negative 10, negative 4, 1, 7, 8, and 3. So this one's a 2 by 3 matrix. This one's a 3 by 2. These numbers are the same, so we can use it. And then the products is going to be a 2 by 2 matrix. So here, I'm going to, remember it's 2 by 2. So here, I have row 1, column 1. So that means I'm going to pull up row 1 in matrix A, turn it on its side, and multiply it by column 1 in matrix B. So there's going to be 3 numbers in this case. And so these 3 numbers are going to be negative 20 plus 3 plus negative 32. I need some more room for the matrix. Let me erase this. Put it right here. Now I have row 1, column 2, so I'm going to use row 1 again, matrix A, turn it on its side, multiply it by column 2, matrix B. So that gives me negative 8 plus 21 plus a negative 12. Now I'm in row 2, column 1, so I'm going to use row 2, matrix A, column 1 of matrix B. So it becomes 0 plus a negative 5 plus 16. Last one, row 2, column 2, put row 2 on its side, multiply the relationships together, so that becomes 0 plus negative 35 plus 6. So if I were to add these together, I would get negative 49, 1, 11, and then a negative 29. So what I've done is just take the products of matrix A times by matrix B. Now it says I have to subtract by matrix E, which happens to be 7, 11, 2, and negative 3. So now we're just going to use the one-to-one correspondence like we did in 3.5. So now it's just negative 49 minus 7, which gives me negative 56. 1 minus 11 gives me a negative 10. 11 minus 2 gives me 9. And negative 29 minus a negative 3 gives me a negative 26. Okay. Example D, I have matrix D, which ends up being negative. You know what I'm going to do? I'm going to change the color so you guys aren't as confused. Let me me change the color here. I'm gonna make it, let's make it blue. So if I make it blue, so that means that if I go matrix D is -3, 5, and 7, and then matrix F is 4, 4, and 6. This is a 1 by 3 matrix. This is a 3 by 1. Again, these relationships are the same. That means that this matrix here is going to be a 1 by 1. So at the end of the day, there's just going to be one number here. And it makes sense because when I take the row in matrix D, flip it on its side, I get -12 plus 20 plus 42. And when I add all those together, that matrix becomes 50, just one number. E, I have D, B, and D. So let me write that down. So I got -10, I got -4, 1, 7, 8, and 3, multiplied by D. So that's what, -3, 5, and 7. So this here is a 3 by 2 matrix, and this one here is a 1 by 3 matrix. I have a problem because these values are not the same, and since they're not the same, this is not possible. Okay? Let's go to example H. Example H gives me D, which is matrix -3, 5, and 7. And then I have matrix B, which is -10, -4, 1, 7, 8, and 3. So this here is a 1 by 3. This is a 3 by 2. Checks out. This ends up going to be a 1 by 2 matrix. So I'm going to have one row and two columns. So taking the row, that one row in matrix D, turning it on its side, which then gives me 30 plus 5 plus 56 for the first one, and then the next one, again, I'm doing that same values, -3, 5, and 7 on its side, multiplying by its correspondence. This is a 7 here, which makes it, what, 12 plus 35 plus 21. Then when I add these together, I get 91 and 68. Okay? So now, here, I want to get some more room. The last two have some parentheses involved, so again, order of operation is important. And what I can suggest is what I would do is I would subtract the two matrices that are in the parentheses and then multiply the product. So let's do that. Let's take E minus C first. So E minus C would be, let's see, let's find what's E. So E is 7, 11, 2, -3, minus C, which is 9, -1, 0, -2, which then if I take matrix E here, again, I'm just going to rewrite it 7, 11, 2, -3, and then this gets multiplied, so 7 minus 9 gives me -2. 11 minus -1 gives me +12. 2 minus 0 is 2. Negative 3 minus negative 2 gives me a negative 1. So now I'm going to multiply these two together to get my matrix. So again, this is going to be a 2 by 2. So I'm taking row 1 of E, and then column 1 of E minus C, which then gives me negative 14 plus 22. I got this one is row 1, column 2, so I'm going to use row 1 of E, row 2 of E minus C, and let's see here, it's going to be 84 plus negative 11. Next one is going to be row 2, column 1, so I have these row 2 of matrix E, column 1 of E minus C, which gives me negative 4 plus negative 6. And then the last one, so I'm going to use row 2 of E, column 2 of E minus C, which then gives me 24 plus positive 3. So when I add those together, I get 8, positive 73, negative 10, and 27. Okay, last problem. I have 2 times matrix B times matrix E, minus that one minus matrix B. So first thing I have to do is I must multiply B times E. So if I take B times E, let's see, I'm going to change the color again. Let's make it red. So B is negative 10, negative 4, 1, 7, 8, and 3. And then I have E, which is 7, 11, 2, and negative 3. This happens to be a 3 by 2 matrix, 2 by 2. It checks out, and that means it's going to be equaling a 3 by 2 because of these numbers. So here I have row 1, column 1. So that's going to be negative 70 plus negative 8. Row 1, column 2, which makes it negative 110 plus 12. Now I'm into row 2, column 1, so that makes it 7 plus 14. I got row 2, column 2, so again, pull it out, turn it on its side, which gives me 11 plus a negative 21. Next one is row 3, column 1, so that's going to be 56 plus 6. Row 3, column 2 gives me 88 plus a negative 9. So from here, I'm going to add these together, which then gives me a negative 78, negative 98, 21, negative 10, 62, and 79. So what we did was the product of B times E. Now I have to subtract this by B. So now I have negative 10, negative 4, 1, 7, 8, and 3. This ends up equaling negative 78 minus the negative 10, Give me negative 68. Negative 98 minus negative 4 gives me a negative 94. 21 minus 1 is 20. Negative 10 minus 7 is negative 17. 62 minus 62 minus 8 gives me a 54. And then 79 minus 3 gives me a 76. Let me write this a little bit better. So it doesn't look like the 8 and the 3 were right next to each other. So now what I've done is got the product B times Z. I've subtracted it by matrix B. Now it says I have a scalar multiplication. So this matrix here gets multiplied all by 2. So if I were to multiply each of those values in the matrix by 2, I would get a negative 136, negative 188, 40, negative 34, 108, and 152. And that's the solution for that one. And that is how you multiply matrices. Hope this helps. Till next time.